Okay, today's video is going to be an introduction to matter. So we're going to go through a few things about matter and how it is made up of small particles. So when we look at matter, what we are talking about is anything that has mass and takes up space. Okay, so if it has mass, takes up space, it's matter. Practically everything we know, except ideas, energy, and dreams, has mass and takes up space, meaning that almost everything, with the exception of those three things, is matter. It comes in four forms: solid, liquid, gas, and plasma. What we're going to look at in this PowerPoint is how we distinguish between those four things. So solids are matter with a definite shape and volume. Okay, so that means if we move that matter to a different container, it's not going to change its shape, it's not going to change its volume. Okay, no matter what we do to that type of matter, it is not going to change in shape or volume. An example here is this rock. If that rock is sitting there, if I pick that rock up and I moved it to a different spot, it's still going to look the exact same. It's not going to mold to the environment that it is in. Liquid, then, on the other hand, has a definite volume, but not a definite shape. So if we have liquid, like, say, a glass of water, okay, that water is going to form to the glass. If we then pour that glass of water into a shallow, bowl, it's going to change shape. It's not going to stay in the shape of the glass. It's going to change the shape to be the shape of the bowl. So that's what we mean when it says not a definite shape. Matter with no definite shape and no definite volume is a gas. So what we mean by that is it takes the shape of the container that it's in, but it also expands to fill that container fully. Okay, so what I mean by that if I'm blowing into a balloon, the air that comes out of my mouth is in a certain shape, right? Kind of a tubular shape. When it blows into that balloon, it expands to fill up the space that it's given in that balloon. If there's a hole in the balloon, the gas is going to escape because it's going to just continue to expand if it has the ability to. Okay, so that's what we mean when we say no definite volume. It's going to conform to the shape of the container. That's no definite shape. And it's going to spread out to fill that entire container. That's what we mean by no definite volume. Now, plasma is matter with no definite shape or volume, just like gas, and whose particles are charged or have broken apart. So we'll learn a little bit more what we mean by charged particles or broken apart. But if we think of matter as like small spheres, okay, it's made up of all these small spheres together. Those spheres either have a charge to them or they're broken down into parts of a sphere when we have plasma. Some examples of plasma: a flame, stars, lightning, a nebula, and the aurora borealis, which is the northern lights, if you've ever seen those. Okay, so all of these things are examples of plasma. Now, plasma we won't go into a whole lot other than what I'm talking about right now, just because it's really hard to study because we have to apply a lot of energy in order to get those particles to either charge or break themselves up. When we're talking about what matter is made of, we're talking about atoms. Atoms are tiny, indivisible particles that make up all matter. They're the smallest piece a substance can get before it loses the properties of that substance. Okay, we'll go a little bit more into atoms when we get into our matter unit. Here are some pictures to help you understand the difference in how that matter is organized. So in the solid state here, notice we have these spheres, like I mentioned. They're all nice and organized. There's as minimal space between them as we can. And if I expanded this box out, my matter would stay in that shape. Okay, it's ordered and dense, has a definite shape and volume, and they're only slightly compressible. In the liquid state, notice we've lost that organization. Now they're still touching, so they're disordered and usually slightly less dense because we could squish these together to make them be a little bit more compact. It has a definite volume, okay? It's going to form to the shape of the container. but they're not necessarily going to spread out. So if I took away like these top ones, it would stay on the bottom. Okay, these particles wouldn't move upwards. Liquids are slightly compressible. They're not as compressible as gases, however, because look at how much space these particles have in the gas state. They could be pushed together very, very compact, which means we have a lot of space there to compress them. So in the gas space, they're disordered. There's much lower density than crystal or liquid, so that would be then solid or liquid. Does not have a definite shape and volume, and gases are highly compressible. Something else to note about these that this picture doesn't actually show is the speed of the particles. So in solid state, the particles are still moving, but they're only vibrating because that's all the space they have. Okay, think about if you're like in a packed bus or train. The only thing you can do is move a little bit, and that's kind of what our solid particles can do there. In a liquid state, they don't have that organization. They can move a little bit more quickly, but they are not moving quick enough to actually separate from each other. And in a gas state, they're far apart, they're moving very quickly, and they're all kind of doing their own thing. We're going to watch this quick video that looks at the states of matter.
The states of matter are gas, liquid, and solid. Gases assume the shape and volume of their container. Particles of a gas are separated from each other, move in straight lines, and in a completely random manner. They change direction only when they collide with each other or the container. Liquids have a definite volume and assume the shape of their containers. The particles of a liquid are closely spaced, and so their motion is still random, but much more limited. The particles slip past and collide with near neighbors. Solids have a definite shape and volume. Particles of solids are in fixed positions and collide only with near neighbors.
Okay, that is the end of this PowerPoint. If you have any questions, make sure you go through your notes and highlight and review your notes. Circle anything you might need to ask questions on to be sure you can ask your teacher.